Welcome. We're about to talk about today a few of my favorite bonds. Here's one of them. Here's another one. But my real favorites are the chemical bonds. So let's do a quick review of what those bonds are. Remember we talked about the ionic bonds. These are the ones that are formed between two ions because of the transfer of electrons. So we have one that wants electrons more than the other. Remember that difference in electronegativity, and then they form because those electrons get transferred and the charges attract. They come together. Remember from the lab, these are very good conductors, so electricity can flow through them, and they also have very high melting points. It's kind of what it looks like. And another one of my favorite bonds are the metallic bonds. Remember, this was like our gold penny lab where we put two metals together making an alloy. And when those metals get together, their electrons just flow together in their sea of electrons. And my last favorite bond is a covalent bond formed by the sharing of electrons. So these are between nonmetallic and nonmetallic atoms. They both want electrons, so they have to come together and share what they have in order for them both to be happy. Remember from our lab that these were not very good conductors. Electricity doesn't go through them very well, and these have very low melting points. So these are the ones that melted very quickly, and some of you even burned them and made the classroom stink up a little. But one thing that we can do with the covalent bonds is draw a picture of it. And you may have seen these pictures before. They kind of look like a bunch of letters and lines. So maybe you've seen water before, something that looks like that. Sometimes it even has electrons floating around up here, kind of looks like Mickey Mouse. Hey there! Sometimes you might have seen just lines. Okay, these are called electron dot structures or Lewis dot structures. It's just a picture of what the molecule looks like. And this is going to help us later on as we start looking at reactivity and how things come together, because what the molecule looks like is very important in how it reacts. There's only certain places where this will react. So let's start out by looking at the beginning here. I'll erase this out. When we're looking at the Lewis dot structures, the first thing we have to look at is just the individual atoms that are there. And we start with what's called electron dot structures. All electron dot structures are the valence electrons. So we know that in this 1A row, this first row, here's our second row, here's row as we get to the other side into the P's, we know that these always have 3, 4, 5, 6. So remember from our talks before, valence electrons in the first row, everybody has 1. So we show the symbol and we give these 1 dot. That 1 dot shows the 1 valence. In the second row, these all have 2 valence electrons. So we put 2 dots around it. And as we go, we keep gaining a valence electron until we get to our noble gases. Remember, our noble gases follow the octet rule, so they have 8 valence electrons, except for helium, because he's the odd one out. Small only wants 2. So as we go across, we just keep putting these dots around. When we put them around, we put them in each side. So imagine that there's 4 sides to this letter. That kind of stands for the S and 3 P's, because that's where those electrons are. And so we fill in 1 until any of them get 2. Okay, so every element will show its valence electrons with this Lewis dot structure. So let's try a few examples here. What would be the Lewis dot structure of these elements? Okay, now it's pretty easy to tell based off of the periodic table because all you got to do is count across. So we know aluminum, we would show Al, and if we count over, it is 3 spots over. So that means it would have 3 valence electrons. Now it doesn't really matter if I put them here, 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 or there, there, and there, as long as it's 3 and each side gets 1 electron before any get 2. How about magnesium? How many spots is it over? Well, if we count, 1, 2. Magnesium is in the second spot, so we'd give it 2 dots. Again, it doesn't really matter as long as each side gets 1 dot before any get 2. How about carbon? How many valence electrons does it have? Well, if you look at your periodic table, it's 1, 2, 3, 4. Remember, we only count in valence electrons the s block and the p block. So we would give our carbon 4 electrons. And neon, it's a special element. Do you remember why? Yeah, it's a noble gas, king of the periodic table. Any of those noble gases except for helium have 8. So 1, 2, 3, 4, 5, 6, 7, 8. We look at how many electrons it has in its valence there. 8 dots. So now let's start putting them together. When we put these atoms together, we use dots and lines to show all the bonding and what's left over afterwards. So in carbon, has 4 electrons. If we bond it to fluorine, you might notice that they're not all spaced out. When we're bonding, sometimes that helps us visualize where it goes. If you were just drawing this carbon on its own by itself, not ready to bond, you'd put it one around each side. But because we're trying to bond it here, we kind of look at how they're going to combine. So if we look at all these dots are going to represent electrons, and any lines are going to represent bonds. Now there are always 2 electrons in a bond because they're sharing. So there's 2 electrons here in each bond. 2, 4, 6, 8. There's 8 electrons here that carbon is sharing with fluorine. So it has its octet. It's a happy little carbon. If we look at one of these fluorines, 1, 2, 3, 4, 5, 6, and there's 2 in this line, so 8. That's a happy little fluorine as well. Okay, so carbon went from having 4 to now having 8, which makes it look like a noble gas. Fluorine went from having 7 to having 8, which makes it look like a noble gas. So that's the reason that all those atoms are sharing. So this is where NaSeL comes in.